Hi everyone, today we're going to talk about logarithm laws. So we already know how logarithms work, how to solve them, how to evaluate them, how to solve for x in a logarithmic equation. We just want to talk about the laws, the rules that are associated with logs, how we can break them down into different things, make them look different. So this whole left column here, 1 through 7, is just going to go through the rules really quick, and then we're going to use them in the rest of these problems. So if we have log base 7 of 25 times 2, so we have log of two things being multiplied together, we can break that down into that log with the same base of 1 plus log of that same base, oops, that's a 7, of the other. So log base 7 of 25 times 2 is really the same as log base 7 of 25 plus log base 7 of 2. Okay, so using that breakdown property, if we have multiplication in there, we can break it down into the addition of two logarithms with the same base. So if we have log of 7x, we can break this down into log of 7 plus log of x. Pretty simple. If we have division, it is subtraction. So if we have log base 5 of 2/3, we can break that down into log base 5 of 2 minus log base 5 of 3. Okay? Again, if we have natural log, same rules apply. It's just the base of e. Now we can just write it with natural logs rather than a base right here. So again, it's division, so we have natural log of 10 minus natural log of x. All right. The next rule is, or next law, is that when you have something to a power, that power can actually be dropped into the front of your equation. So it actually can just go right in front right there. Now the reason why this is because this is actually saying log base 4 of 7 times 7, which is the log base 4 of 7 plus the log base 4 of 7. Well, we have two of these, so we could just say it's 2 times log base 4 of 7, which is the same as dropping down that 2 in front. So we're going to use that rule a lot. So looking at this next one, natural log of 2 to the x, we can just rewrite that by saying, hey, we're going to drop down this power, even if it's an x, so that it's x natural log of 2. It makes our life a lot easier in the end to do this. And then the very last rule is one that seems kind of intuitive, and it is if you have log of the same base of a number equals log base 6 of another something, say x, if they're equal to each other, x and 2 have to be equal to each other. So x has to be 2 in this case. If you want to use what we learned about in our other logarithm video with solving for x, these both have a base, log base 6, so I'm going to raise them each to the 6th power. That cancels out this log, so we have 2 equals x. So it seems really intuitive, but it's nice to know as well. Alright, so we're going to use these rules and work on some of these problems over here now. And I think I'm actually going to keep with purple. So we just want to split all of these logs in 8 through 11 into some form where we have addition and subtraction. We want them only as logs of a certain thing. We don't want this complex log. So we're just going to look at the numerator first. So when we see the numerator, we have an x squared and a y cubed being multiplied together. So that means we're going to add those two separate logs. So we have log base 7 of x squared, but since that's a power of 2, I can bring that power down in front, and then I'm just left with x. There's multiplication going on, so I'm going to add log base 7 of y to the 3rd. Since there's a y and a power of 3, that 3 can be brought down. All right. And then I have division, so I'm going to put a big old minus sign right here. And then we're going to subtract everything from there on out because it's all in the denominator. So I'm going to put parentheses. And actually, since I'm running out of room, I'm going to put it down here. Shouldn't really do it, but space, I didn't plan very far ahead. Alright, so we're going to take log base 7 of m, and since these two are being multiplied together, we add the log base 7 of n. This minus sign is going to be distributed to the log base 7 of m and the log base 7 of n. So they're both going to be subtracted. So if you want to write it like that instead, get rid of the parentheses and change this plus to a minus, that's fine as well. Okay, let's try the next one. So we have log base 3 of the square root of 5 times a to the 7th. Well, right away, you should recognize that the square root is really just saying to the 1/2 power. And since we know it's a power already, let's go ahead and drop that down. So 1/2 log base 3 of 5a to the 7th. So everything's getting multiplied by that 1/2. Okay, now we can just do this log base 3 of 5 times a to the 7th as we normally would. So this 1/2 is out in front now. And we're multiplying that by log base 3 multiplication, so we can split it up, of 5 with addition, log base 3 of a to the 7th, but that power we can drop down in front. So I'm going to put it right here. So plus 7 log base 3 of a. And that is it. All times that 1/2 power. So you can distribute that through if you want to. You don't have to though. Okay, let's try this guy. So we have 5 out in front. Or maybe you should try these right here. 10 and 11, try on your own while I do them after you've paused the video. Okay, we're back. So we have log base 4 of this guy. So we have multiplication going on. So that 5's on the outside. I'm going to keep it there. And we're going to break down that numerator to be 2 log base 4 of a, drop down that power, plus log base 4 of b, minus, because we're doing division, and that n to the 3rd power, I'm going to drop down that 3, so I have log base 4 of n, all being multiplied by this 5. Did you get it right? Because that's one of the hardest ones. Okay, let's try this one down here. So we see that it's to the 4th power right away. When we see that, we can drop down the power, and we should be good to go after that. So we have 4 log base 2 of b over c. And now we can use our division property. So log base 4 times log base 2. I'm going to put a parenthesis right there, because that 4 is being multiplied to everything. Log base 2 of b minus log base 2 of c. And make sure you have your parentheses in there. Okay? Alright, so we know how to do these now. Let's make sure we know how to combine logarithms now. So instead of expanding them, let's look at the expanded versions and condense them. So notice they all have to have the same base. They all have log base 5 in this example 12, so that's a good thing. Since they're being multiplied together, our multiplication rule was what split everything into addition. So this is really just log base 5 of 2 times 3. So log base 5 of 6, you could say. Okay? Next one, we have some addition, which means multiplication in the end. And we also have some subtraction, which means division. So what we want to do is write log base 3, because they all have the base 3. And then what are we doing here? We have 3 plus the 6, so that's actually 3 times 6. And then minus means division, so we're dividing by 2. So that would be 9. 3 times 3. So log base 3 of 9. Okay. Over here, we're not working with numbers anymore, we're working with letters or variables. So we have log m plus 2 log n. If anything's in the front, that's actually something that can be put in the power. So we can think about this as log of n squared. This is addition, so we can say log of m times n, and then that 2 going back into the exponent to be m times m squared. Okay? Try 16 on your own, see if you can do that one. Okay. So first we're working with the inside part. So always do the inside of the parentheses first, as PEMDAS always says. So we're going to have the 6 out in front. We see they're the same base, 8, awesome. That means we can combine them, condense them. There's subtraction going on, so that means when we have this log base 8, the 5 is being divided by the m. So we have over 5m. And we have this 6 out in front still. That 6, just like it did over here, excuse me, this 6 is just like the 4 over here. So we had 4 log base 2 of a quantity. This 4 actually was the power to that entire quantity. So what we can do, log base 8 of 5 over m, oops, that's an m, that's actually to the 6th power. So that we can drop that down right away and then undo everything accordingly, and it will give us 16. Okay? All right. So that is the logarithm laws. So we have these addition and subtraction properties. We have dropping down that power, and if the two things are equal, if the two things have the same base and they're equal to each other, the logs have to be equal to each other. So it's just a lot of breaking things down, using those rules, rewriting them to help solve equations and things like that. So if you'd like some more practice, here are some more examples. Now I'm not going to take time to do these in the video just because I don't want the video to get too long, but if you want to, you can try them on your own and then maybe go into wolframalpha.com and type these in and it will help you solve them. So Wolfram Alpha, I'll write that down at the top of this page. That's a great resource. So wolframalpha.com. Okay? So Wolfram Alpha, it's a great resource for solving any equation or evaluating expressions or graphing things, so use it. And if you need help typing things in, come in and see me, or there's great resources on that website to help you type these things in. All right, otherwise I'll see you later. Bye.